What if I told you that Saturn's rings, those shimmering halos, are younger than the dinosaurs? Recent supercomputer simulations reveal a dramatic collision between two icy moons, forming Saturn's iconic rings. This cataclysmic event, just a few 100 million years ago, also shaped some of Saturn's current moons. Imagine the aftermath of such a collision, with icy debris scattering into Saturn's Roche limit, forming the rings we see today. NASA's Cassini mission hinted at the rings' youth, sparking further research into their mysterious origins. Saturn's rings are almost entirely ice, a clue that puzzled scientists until these new simulations provided answers. When icy moons collide, their rocky cores remain intact, while the ice spreads out, creating ice-rich rings. This collision likely triggered a cascade of impacts among other moons, reshaping Saturn's satellite system. The gravitational interplay between the Sun and Saturn's moons could have destabilized orbits, leading to these collisions. Saturn's moon Rhea, with its circular orbit, suggests it formed more recently, avoiding gravitational disruptions. Cassini's observations revealed the rings' age and mass, with over 95% of their mass composed of water ice. Micrometeoroid bombardment darkens the rings over time, offering clues to their exposure age. Current estimates place the rings' age at less than a few 100 million years, supported by their mass and composition. Remarkably, Saturn's rings are losing mass rapidly, making them ephemeral in cosmic terms. Earlier theories suggested the rings formed billions of years ago, but new evidence points to a more recent origin. Saturn's system of moons offers clues to its dynamic history, with some moons forming or reforming outside of disruptions. Tidal forces acting on Saturn's moons reveal complexities, with some moons migrating outward faster than anticipated. High-resolution simulations show how debris from moon collisions could form rings or reaccrete into moons. These simulations suggest collisional cascades reshaped Saturn's satellite system, delivering material to create the rings. Could icy moons like Enceladus, with its subsurface ocean, have formed recently enough to retain conditions for life? Saturn's rings remind us that even seemingly permanent celestial features are subject to change, revealing the dynamic processes of our solar system.